Today I will be cooking this chicken and rice dish and explaining the chemistry behind it. Here are the ingredients that I used to make the dish. The ingredients are brown rice, boneless chicken breast, Greek seasoning for the chicken, and finally canola oil so the chicken doesn't stick to the pan. Here I am preparing to put the chicken in the oven. I set the oven to 350 degrees and I'll be putting it in for around 25 minutes. Now here I am putting the chicken in the oven, and now that I've put it in the oven, a reaction will occur known as the Maillard reaction, which happens when cooking meat such as chicken. The Maillard reaction is a reaction between the amino acids and the reducing sugars of the chicken, which results in a flavorful baked chicken. Now while I wait for the chicken to cook, I will start preparing the rice, which I am doing here. I use 2 cups of water and 1 cup of rice, and I will put it on the stove until the water starts to boil, which I will then let it simmer with the lid on. Now that the chicken is in the oven, the first reaction that will occur is a change of colors, which is part of the Maillard reaction due to non-enzymatic browning, which is caused by the reaction between the amino acids and the reducing sugars. The rice will start off super hard, and then when it is finished cooking, it will be very soft, and this is due to a chemical change called gelatization. Rice undergoes a chemical change instead of a chemical reaction because the substances react with one another to undergo a change in composition. Brown rice is composed of the elements of magnesium, phosphorus, selenium, thymine, niacin, and manganese. While I let the rice simmer for about 15 to 20 minutes, I check up on the chicken, which should be undergoing the second step of the Maillard reaction, which is the reaction of cysteine and sugar, which is responsible for the flavor of the chicken when it is finally cooked. There are many other smaller reactions that lead to the flavor of the chicken, but that of cysteine and sugar are the main one. I wait for about 5 minutes and then check back up on the rice, and it is looking like the water is finally starting to absorb into the grain, which is expanding the rice, and at the same time the heat is softening the starch of the rice and getting rid of the hard shell that it initially had. I go and check back up on the chicken, and it is looking like it is almost done, so it must be nearing the end of the Maillard reaction. What is most likely happening now is that the bonds of the protein molecules are breaking and the coils begin to unwind, thus giving a cooked chicken more protein than a raw chicken would have. I wait for a few more minutes, and then I notice that the rice seems to be fully expanded and softened. However, there seems to be a little bit more liquid on the bottom, so I must let that get absorbed. The chicken is finally done, and as I am taking it out, I notice a change in color, but I also notice a change in density from when it was raw. This is because when the protein fibers are exposed to the heat of the oven, they expand like elastics. Just a few minutes after I take my chicken out, the rice appears to be done, so I stir it around to make sure there is no remaining liquid, and then take it off the burner, because if I leave it on for too long, the grains will begin to split. As I prepare a dish for myself of the chicken and rice, they both appear to be well cooked, thanks to the chemical reactions and changes that took place today.